We're going into factoring polynomials, okay? Basically, what we've been doing is FOIL. We've been multiplying. Yes, we're doing the box method and all that stuff. You guys remember that? What we're going to be doing now over the next few lessons, okay, is factoring polynomials, and it's going to be pretty much the same thing that you were doing, just undoing it, okay? So, like, let me ask you this. How do you solve this? What is 3 times x plus 5? What would that be? What would I do? I would distribute. I would take the 3 and I would multiply 3 times x and I would get 3x, right? And then I would multiply 3 times 5 and get 15, correct? What we're going to be doing today is I'm going to start with this, and this would actually be my answer. So we're undoing what we're trying to figure out. Does everybody understand that? Kind of, sort of. We're undoing distributed property. Now, we're not going to undo the FOIL method today. We're going to get into that later. Today is all about greatest common factor. We're going to find a factor that goes into both terms, okay? And then we're going to undo it, okay? We're going to unmultiply it or divide it or factor it or whatever you want to call it. Fair? All right, let's go into the first few examples. All right, let's follow this worksheet. I am not going to go through it. If you guys have your worksheet in front of you, if you look on the back, there are like 24 examples. I am not going to talk through all 24 examples. I'm just not going to do it, okay? This will be a pretty fast notes as long as we kind of show me that you understand it, not all that other stuff. Just pay attention, follow along with me, and we're going to be cool. All right, so here we go. Click. There we go, notes. Main idea, simplify the following polynomials. Now, this is what I just showed you a second ago. How would I solve this one? What's a times 3a, guys? 3a squared, that's exactly right. So we got 3a squared, and then we've got a times 7, which is what? 7 what? 7a. All right, everybody good so far? Same thing as the other ones. Negative 2m times m squared. Now, what's the number? Negative 2. It's negative 2, right? That doesn't change. So negative 2, and we've got m1, m2, m to the third power. Good. Negative 2 times 6 is negative 12, and then we got m times m, which is m squared, and then we got negative 2 times negative 1, which is positive 2m. Remember, anytime you multiply times negative 1, it's the same thing again. The signs just switch. Yes? Let's talk about the third one. Okay? Now we're getting a little crazy. Okay? Remember, don't overthink these. What's 4 times 1? 4. Okay, so we got x3, x2. Add them together. What do we get? X what? X5. So the x's are done. See this y that's still there? I'm just going to put it right there on the end because there's nothing to combine it with. Does that make sense? Okay, so now let's do this. What is 4 times negative 2? Negative 8. Okay, so I've got x3, and there's no x here. So what do I do? X3, good. I've got y, and then y. Y squared. Okay, everybody good? You see how I did that, though? One letter at a time, not trying to do too much. If you look at this and you're like, okay, that's a lot of letters, but if I go letter by letter, number by number, it's really not that big of a deal. Just add the exponents together. Would you agree with that? Just be very, very simple with what you're doing. What we're going to do today is we're going to undo this and put it back how it went, okay? That looks like it's going to be really, really hard. It's not that bad, okay? But you have to do it by letters and numbers separately. Okay, that will make things a whole lot easier. So what is factoring? Here we go. What is factoring? We're going to go from simplest form over to factored form. Now, let me write the example that they put on the notes because everything that we have this filled out on your canvas, okay? So I want to make sure that we follow along exactly what they have. So they got 4a squared. We're going to go from 4a squared plus 8a to this right here. 4a, then parentheses, a plus 2. Now, I will explain how we get to that point here in just a minute, okay? I can probably already, well, I was thinking about going ahead and explaining it, but I'm not going to yet. Polynomials that cannot be factored are called what? Think about it. What kind of numbers don't have numbers that go into it? What are those called? Like 7. What is 7? It's what? It's a prime number. Polynomials that cannot be factored out, they're called prime. Okay, they are called prime. In other words, if we ask you to simplify 3x plus 5, there's nothing that will go into 3x plus 5. That is my answer. That is as far as it gets factored. Okay, there's nothing I can do to unfactor it. It is prime. All right, here we go. There are several different factoring methods. Now, I'm not a big fan of reading a whole bunch of words, but I'm going to on this one. Okay, there's a lot of information on here. There are several different factoring methods. The approach depends on the polynomial. We'll start by identifying, factoring out the greatest common factor. The greatest common factor is always going to be your first step when we're factoring. Okay, whether we're talking about trinomials, whether we're talking about whatever, you are always going to look for a greatest common factor. Is everybody with me on that? You always look for your greatest common factor first. What is the greatest common factor? It is the biggest number or letter that goes into every term that they give you in the problem. It has to go into everything. Does that make sense? Like, let me back up a little bit. We had this, didn't we? 4a squared plus 8a, right? What goes in? Let's start with the numbers. What goes into 4 and goes into 8? And the greatest factor, the greatest common factor would be 4. Would you agree? Okay, so that's why the 4 was on the outside, because that's the greatest common factor. It has to go into both terms, or all 3 terms, or all 4 terms, depending on how big the problem is. Okay, it can't just go into one number. It has to go into everything. Okay, so we're going to identify the greatest common factor of the polynomial. Check the coefficients for a greatest common factor. That's what I just did. I did the 4 and the 8. Those are the coefficients. And what I always tell people, what's bigger, 4 or 8? 8. So start with the smallest number. Start with the 4, because 8 won't go into 4. You have to start with the smallest number. It won't be bigger than the smallest number. If the smallest number is 4, it's guaranteed not to be above 4. Because will anything above 4 go into 4? Will 5 go into 4? Will 8 go into 4? No. So you start with the biggest number and work your way down from there. Will 4 go into 4? Will 4 go into 8? Then it works. So always use that smallest number first and see if that works. Because if that number works, you're guaranteed to already have a number. All right? Then we're going to look at the variables. A variable must be present in all terms to be a greatest common factor. Okay, so if I have an A in both of them, that's my greatest common factor. Okay, that is my term that goes into both. If I have a B or a C or whatever, I'm going to be looking at variables. Okay? All right. Do you guys need me for something? I have a piece of mail? Okay. Oh, softball. Yeah, you want to, I'm recording YouTube. You want to say hi? She's like, nope, not really. Okay. See you. You got what? Nah, it happens. I'll see you. Sweet. Softball. Okay. All right. That was Softball Magazine. All right. Everybody cool with this? So we're going to explain this. Obviously, there's a lot of information to go through here. We're going to divide each term by the greatest common factor, then check your work by distributing. So after you solve it, you can distribute back and see if you come back to the original problem. If you don't, then you did something wrong. All right. Here we go. Factor each polynomials. Everybody here? Everybody good? What did it say to start with? Did it say start with the letter or the coefficients? Coefficients. So what are my 2 coefficients on the number 1? 3 and 12, right? Now, pick the smallest one. What's the smallest? Okay. Will 3 go into 3? Well, obviously. Will 3 go into 3? Will 3 go into 12? Yes, it is. So that is my greatest common factor. We are going to factor each polynomial, check your work by distributing. All right, so here we go. So we're going to take this 3, and I'm going to bring it out. You guys with me on this? I'm bringing the 3 out. What is 3 divided by 3? 1. Now, I'm going to put this right here. I'm going to put it as a dashed line, because if I put something else there, then I can get rid of the 1. Does that make sense? Just stick with me on this. Now, plus, will 3 go into 12? How many times? So I'm going to put a 4 over here. Okay? Is everybody good so far? Now, what's left? What have I not touched yet? The x. Is it on the first term or the second term? First term. So now I can get rid of that 1. Now I can get rid of the 1 because there's something there. Do you ever see 1x? No. The reason I put the 1 in a dashed line is because there was nothing there initially. But once I put the x there, I can get rid of the 1. Because now let's check it. What's 3 times x? 3x. What's 3 times 4? 12. Solved. We're good. We checked it. Everything matched up. We're good. Everybody semi-good with this? All right. So what's my greatest common factor number 2? I have a 7 and a 7. Okay, what's 7 divided by 7? 1. What's 7 divided by 7 again? Now that one I'm going to put a solid 1 because there's nothing else there. So I know this is going to be it. Do not cancel it out. You have to put something there. If there are 2 terms in the problem, there should be 2 terms in your answer inside the parentheses. Does that make sense? Because if I don't do that, first of all, if I take out the 7, I still got the y. Yes? If I just put 7y, let me show you this. If I just go 7y and I'm like, okay, well, the 7 cancels out. Okay, great. But if I go 7, what's 7 times y? Does that match our problem? No, I've got to have a second number to multiply by to get to that negative 7 on the end. Everybody make sense? Yes? Nod? Tell me. We're good? I see a lot of nodding, so we're good. All right. All right, here we go. Third one. I have an 8 and I have a 36. What's the smallest number? Okay, 8. Will 8 go into 8? Cool, that's good. Will 8 go into 36? Evenly. No, it will not. If you don't know, go 36 divided by 8. What'd you get? 1, what? 4.5. It doesn't go in evenly. Okay, so what's the next number down? Okay, let's talk about the numbers that go into 8. So if we're talking about 8, here's how I always did it. I went, this, okay. What 2 numbers multiplied to be 8? 2 times 4 and what? 4 times 2 and what? 1 times 8. Well, we've checked out the 8. What's the next number down? 4. Will 4 go into 8? Yes. Will 4 go into 36? There's my greatest common factor. How many times does 4 go into 8? 2. And there's a what letter on the end? M. Because what is 4 times 2m? 8m. Okay. And I'm doing the letters now because the letters are different. So I know there's not a factor between them. Okay. How many times what's 36 divided by 4? 9. What letter? N. We're done. And because the letters don't match, there's nothing I can bring out of it. Cool? You guys want to try number 4 real quick? Okay, try number 4. Go. I have a 5 and a 30. I wonder if we'll pick up on that on the video. I just popped my neck. It was nice and loud. Can I just give you the answer? See if you got it. So I see a lot of thumbs up if that's what you got. Perfect. Looks like about everybody. Okay, good. We're good on that? All right, let's go flip the page over. I don't think we need to do number 5. Number 5 looks a lot like the one we just did. All right, let's look at number 7. I like number 7. This is the first class I've taught this to this year, so I like kind of jumping around. I might do different problems when we get to the next class. All right, let's look at number 7. What are my 2 coefficients? 21 and -3, right? Okay, so you don't necessarily need to worry about the -3. Just I have a 21 and a 3, right? So what are my numbers? What's my smallest number? 3. Will 3 go into 21? Then that's the one I want. Always check your smallest one. If it doesn't work down from there. Everybody's good with that, right? Work down from there. So the number is 3. Now we'll get to the letters in a minute. Okay? You notice I'm putting a little space? That's kind of a clue. All right. What's 21 divided by 3? 7. Minus, what's 3 divided by 3? 1. So you can put a dash line. I'm just going to put it solid. Okay, not a big deal. Now, what matches? I have a C and a D, one of each, and I have a D here. Okay, what letter matches? D. So I pulled 1 out. Yes? This is important. Please pay attention to this. I pulled 1 D out. Okay? So this gets rid of 1 here and 1 here. So what's the, oh, I've already taken care of that 3, right? Yep. So what's left? Done. No, because if I multiply, because if I go D here, what's 3 times negative 1? Be negative 3, right? Yes? What's D times D? Do we have D squared up there? No, we do not. Okay. So that's why we always double check. Okay, so don't do that. Because now what's 3D times negative 1? Negative 3 what? That's what we have. Okay? I see people nodding like, oh, okay, that makes sense. Everybody good with that? All right, let's go to Kenley. Why don't you pick one? 11. Let's go to 11. AB minus A. Now it's all the way down there, but I'm going to put it like up here. Fair? Because I'm 6'5", and that's what I want to do. Okay. I just don't want to bend over. AB minus A. This is number 11 down the bottom corner. All right. Is there a number? So just go to the letters. No big deal. What letter matches in both of them? So pull A out. Go. You can do this. How many terms are there? 2. So how many terms should there be in parentheses? 2. There should be 2 terms in the parentheses. Yes? Trust me. Remember, what's the number in front of that A if there is no number? There's a 1 there. This one's kind of tricky. I think she tried to get the easy one, but this one's probably one of the more difficult ones. What letter comes out? Okay, so if we pull A out, that gets rid of that. That gets rid of that, right? So what's left? B what? Minus 1. Because what's A times B? AB. What's A times negative 1? Negative A. You got to have that second term. You cannot just get rid of it. I see a lot of like, oh, okay, that kind of makes sense. Is this maybe clicking a little bit now? Starting to make a little sense. Are there any problems with this page? Nope. You want to have some fun with this? Yikes. You're fine, no big deal. So let's go to 3 terms. So let's go to 14 just for the fun of it. Let's go to 14 because there's only 2 terms. There's 2 terms. Everybody with me? There's 2 terms. All right. Find me the number that's the greatest common factor. Go. Start with the factors of 18. Figure it out. Yeah. It is 6. She did it for you. Okay. If you don't know, you can work your way down. When I think of 18, I think of 18 times 1, 2 times 9. That's how I always did it. 1 and 18, 2 times 9, 3 times 6. What I would do is work my way down that line. That doesn't work. That doesn't work. That one will work. Okay. Everybody with me? That's the way I always did it. There's a lot of different ways you can do it. Okay. So we're going to pull 6 out. Am I worried about the letter yet? No. He noticed I'm putting some space. Actually, I'm going to put it down here towards the bottom. So we've got 6, parentheses. How many times does 6 go into 18? 3. Yeah, 6 times 3 is 18. No. So we got, oh, no, sorry. That's 6. So it's a 3. How many times does 6 go into 48? Say it. Now say it. 8. Is everybody good? Now, please watch this because it's not overly complex, but this is where I kind of start to lose people. Okay? When we're talking about variables, when we do the greatest common factor, you should not have matching variables in the terms. You should not on the inside of the parentheses. Okay? Like the answer, you should have an X and a Y or an A and a B or whatever. There should not be an A and an A. Because if you did that, that means you didn't pull enough of the A's out. Okay, so let's start with the letters. How many A's are here? A to the what power? No, not this one. How many A's? There's 2 of them, right? How many are here? There's 1. So how many do they have in common? No, in common. There's 2 here, there's 1 here, so they both have at least how many? They all have at least 1. You're always going to pull out the smallest exponent on the variables. You guys stick with me on this, okay? So if I pull the smallest exponent out, A, how many did I just take out? I had 2. I took 1 out. How many are left? No, I had 2. I took 1 out. How many are left now? There's 1 left. Because if I multiply A times A, won't it be A squared? Everybody with me? I had 1. I took it out. Are there any A's left over here? No. That one's no. So we're done with the A's. Now what's my next letter? B. How many B's are here? How many are here? Pull 1 out. Done. B is done. A's are done. Now, let's look at the C's. I have C to the 2nd power. I have C to the 3rd power. Which one's the smallest one? C2. So I'm going to bring out C to the 2nd power. Okay, so watch what happens. So I'm going to bring out this C to the 2nd power. So there's no C here because we just basically dropped both of them right here, didn't we? So we can't have an extra one. But how many C's were here? There were 3 here. I brought 2 over here. So how many now go back inside? Okay. I've heard somebody call these like socks. You know, you're matching up pairs and whatever else. And whatever doesn't have a pair goes back to the basket. I don't know. Yes?
So is there always only 2 of the same one?
Not always 2. It could be 4 or 5. Whatever the smallest exponent is. We have A2, A1. 1 came out. But if you notice, what letter is here? What letter's here? They don't match. There's no letters that match in the parentheses. But if I distribute, what's 6 times 3? Nope. Hold on. I'm just going to do 1 distributing. Okay? 6 times 3 is 18. Yes? A1, multiplied, I get what? A2. B, how many C's? There it is. Okay. All right. Let's get something with some numbers that aren't crazy. How about, Charlie, pick one. 17. Let's do 17. I have a 6, a 14, and a 10. Okay, go. And I have Y4, Y3, Y2. Go. See if we can do it. I'm going to pause it. Maybe, if I could pause it. Maybe. Okay. I just unpaused the video. I put the answer. This is the answer to that. Remember, I'm 6'5", so I don't like, it's kind of an awkward angle to write. Okay, is everybody with me? Look at your answer. Where did you make a mistake? Go ahead. Yep, you got to divide. That's a very, very common mistake. Now, did everybody get 2? Did everybody get 2? Let's start there. I see a lot of nodding. Everybody got 2. Everybody's good, right? So then we divided, we had the 2 on the front, so we divided everything by 2. Divided everything by 2. Divided everything by 2. That's where these numbers all came from. Okay? Yes? Now, I had Y4, Y3, Y2. What's the smallest one? Y2, correct? So I had Y to the 2nd power, so I brought them out. Hey, everybody look. I had 4. I brought out 2. How many are left? 2. That's where this came from. Because if I add those together, I go back to Y4. I had 2. I'm sorry, I had 3. Brought out 2. How many are left? If you notice, all I'm doing is just subtracting the exponent. That's all I did. I just subtracted them. Make sense? You want to try one more? Can we have some fun with it? Let's see what's... How about... Can we try 24? Look at it. Is that too much? Letter by letter. Can you do letter by letter? Just one letter at a time? All right, we're going to try 24. I'm going to pause the video. Then we're done. 24. Hey, the numbers are only 3, 9, and 15. What's the smallest number of 3, 9, and 15? So check 3 and see if it works. Right? It's a prime number, so it's either going to work or it's not. Okay, this one I am not going to just give you the answer. I'm going to literally walk through it. Okay, I'm going to walk through this whole thing because there is a lot going on. Shout out to my stepdad, Ron. What's up, Holly? Hey, he had a birthday the other day. He's like 95 or something. I don't know. Maybe not, but whatever. All right. I joke about him. All right, he's getting old. All right, here we go. What number goes into 3, 9, and 15? 3. Okay, so let's do this. If you notice, I'm gonna do it like this. I'm gonna try to put the numbers or the parentheses literally right under the other ones. Fair? 3 divided by 3 is 1. 3. That's -3. +5. Is everybody good? Did everybody get the numbers right? Yes? All right, I want to make sure we're good. All I did was I divided the front numbers. That's all have I touched the letters yet? No, I have not. All right, what's my first letter? What? A. All right, I'm gonna cross off the numbers because the numbers are gone. Fair? All right, let's focus on A. We have A3, A2, A1. What's the smallest one? A1, so just one A. I had 3. I brought 1 out. How many are left? I had 3. So now this is 2. So now I can get rid of that 1 there because we don't need that anymore. Okay? Everybody understands what I just did, right? I had 3 of them, which is like A, right? I brought 1 of them out. The 2 remaining ones went back inside the house. You look confused. Are you okay?
I just don't know because I put A3 into the next one.
Nope. No. How many A's are here? How many did I bring out? Nope. How many went out to the front? 1 went to the front. How many go back inside? 1A. It's always subtracting. Okay? And then our A1 here is gone because, well, that's what we brought out. Everybody good? Does everybody understand? That's fine. That's why I'm walking through this. Does that make sense? Okay? It's almost like I have like 7 socks. If I bring 3 out, I'm going to have 4 left inside. Okay? All right. What's my next letter, guys? B. So the A's are done. I have B2, B3, B4. Which one's the smallest? B2. So B to the second power goes there. So I had B2. I brought out B2. Are there any B's left? That one's done. I had 3. I brought out 2. What's left? 1B goes inside. Brady, you good? Okay, you just had a confused look on your face for a second. Sorry if it's, I don't know, just your face. Okay, all right, here we go. So we had B4. Hold on, we had 4. 2 went out. How many go back inside? 2. B to the second power, go back inside. So that's done. Is it making sense now? And if I go letter by letter, it's not as bad, is it? Now what's my next letter? C1, C2, C3. What's the smallest one? C1. That's this one. C1, it's gone. There were 2. I brought 1 out. How many are left? Okay. C1. There were 3 here. I took 1 out. How many are left? We're done. There's my problem. Can you do this? Is it possible? It's not, you're not really solving. You're just undoing math is all you're doing. You're just undoing, okay? Now, what we're going to do, you have this entire sheet of problems, yes? What I want you to do give me, what time is it? I can't, my watch is recording. Oh, give me 10 minutes. Give me till about noon. Okay, what I want you to do is work with a partner. Okay, I don't want you moving around to the back of the rooms. I don't want you doing that. You don't even need your Chromebooks. Just use your calculator, okay? I want you to work for 10 minutes on the problems that we have not touched on your worksheet and work through those, okay? Everybody good? If you want to check your work, I have the key up here and it will be on the front of the room. Cool? All right, let's go to work. Don't forget to like and subscribe. Share it with your friends.